If you've ever dipped your toes into coding, you have definitely seen the Hello World program. It's like the traditional first handshake. But have you ever actually stopped to think about what each little part of it really does? Well, today we're going to put this classic program under the microscope and really dissect its anatomy line by line. And here it is, our specimen for today. Now, it might look incredibly simple, but trust me, these few lines are absolutely packed with the fundamental ideas that make pretty much every piece of software work. We're about to break this down and figure out the job of every single word, symbol, and punctuation mark. So, where do we start? Right at the very top. Just like any good project, before you can start building anything, you have to get your tools ready. And that's exactly what this first line of code is doing. This line right here, #include stdio.h, is actually a special instruction. It's a command that runs before our main program even starts. It's basically telling the computer, hey, go grab this file called a header file and get it ready because I'm going to need the stuff that's inside it. So what in the world is a header file? Well, the easiest way to think about it is like a toolbox. It's a library that's full of pre-written, ready-to-use tools, we call them functions, that we don't have to build from scratch. By including it, we're essentially just grabbing that whole toolbox for our project. The specific toolbox we're grabbing here is called Standard Input Output. That's short for Standard Input Output. And just like the name says, it contains all the essential tools for getting information into our program using something like scanf, and for getting information out of our program, which we're about to do with printf. So really, when you get right down to it, that first line is just us saying to the computer, hey, I'm going to need the tools for input and output for this job. It's just a simple request to get the right equipment before we get started. And this line, it is not optional. If you forget to include this header file, when the computer gets to the word printf, it's going to have no idea what you're talking about. It's like trying to use a power drill without plugging it in. The result? You get a compiler error, and your program just won't run. Period. Okay, so our tools are ready to go. Now it's time for the main event. Every story has a beginning, right? Well, every C program has an official starting line, and the computer is trained to look for it. And this is it, int main. This line declares what's called the main function, and this is non-negotiable. When you tell the computer to run your code, its one and only mission is to find this exact line and start executing whatever instructions it finds inside. This is the official front door to every C program. Now, I just used the word function. What is that? Simply put, it's just a named block of code that's designed to do one specific thing. You can think of functions as the Lego bricks of the software world. Every complex app you use is just built from thousands of these little specialized blocks working together. And main is the special one that gets the whole party started. But what about that little int at the very beginning? What's that for? That's a keyword, and it's like a promise. It's the main function telling the operating system, hey, just so you know, when I'm all done with my work, I promise I'll give you back an integer, a whole number, as a kind of status report. We'll see exactly how it keeps that promise in a little bit. And then we have this guy, the opening curly brace. Its job is incredibly simple, but absolutely critical. It just marks the beginning of the main function's territory. Everything that comes between this opening brace and its matching closing brace belongs to the main function. We've set the stage, we've found our starting point, and now we are inside the function. This is where we get to the real heart of our little program, the single command that actually does all the work. So, let's meet printf. This is one of those useful tools that we got from our stdio.h toolbox. Its name is short for print formatted, and its entire job in life is to take some piece of information and display it on the screen for us to see. So what information are we telling it to print? Well, whatever is inside these parentheses and wrapped in double quotes. In programming, a piece of text like this is called a string. The quotes are a signal to the computer, telling it, hey, treat this as literal text to be displayed, not as a command you need to figure out. And you see that tiny little semicolon at the very end? Do not underestimate this little guy. In the C language, this is like the period at the end of a sentence. It tells the compiler, okay, this specific instruction is finished. You can move on to the next one. Forgetting it is probably the most common mistake for beginners, but it is 100% mandatory. So our program has done its one and only job. It's printed our message. But before it can officially clock out, it needs to report back to its boss, the operating system, and let it know how things went. And this is where return 0 comes into play. Hey, remember that promise our main function made with the int keyword? This is it, keeping that promise. By returning the number 0, our program sends a status code back to the operating system that basically says, all clear, everything went perfectly, no errors to report. It's a universal code of conduct in programming. Returning a 0 means success. If something had gone wrong, like maybe a file was missing, the program might return a 1 or some other number that's not 0. And that would be a signal to the operating system that an error happened. It's a super simple but effective system for reporting back. And finally, we have our closing curly brace. Just like the opening one signaled the start of the main function's code, this one signals the end. The to-do list is done, the function is over, and it's time to go home. So now that we've looked at every single nut and bolt under the microscope, let's zoom back out and just watch how the whole thing flows together from start to finish. So let's trace the journey. First, the compiler preloads our toolbox from stdio.h. Then execution jumps right to the starting line, the main function. Inside, it calls the printf function, which makes hello world pop up on our screen. Finally, it sends that all clear signal by returning 0, and the program's job is officially done. It's a clean, logical flow every single time. So what's the big takeaway here? It's that in code, there is no wasted space. From the hashtag symbol to the curly braces to that final semicolon, every single character is there for a reason. It has a precise and important job to do. Programming really is a language of precision.